What's going on, guys? Today we are going to create a simulated environment in Python, which we are later going to deploy an artificial intelligence agent within in order to determine the best actions to take in order to accomplish our goal within that environment. Okay, so I'm going to go ahead and I'm going to run this for you guys here. So this is what this script is going to do is simulate this environment for us, and then we're going to later talk about how you can create a neural network in order to determine the best way to go about this. So I'm just going to jump right in here. So this is what we got. Okay, so what we're trying to do is balance this pole on top of this cart indefinitely. Okay, so what we are seeing right here is a number of simulations being run where, based on our policy, which is the actions that the cart is going to take in order to balance that pole on top of it. So based on that policy, we're trying to see how long can we maintain balance. Okay. So we're going to talk in this video about how we can create this simulation, and then later about how we're going to implement a neural network for this reinforcement learning problem in order to best create the policy and determine the best actions to take in this environment to accomplish our goal. Okay, so let's talk about. So what is this? How do we create this environment? What's going on here? Okay, so the first thing we're doing is we're importing a module called Gym. Okay, so Gym is a Python module that OpenAI has created in order to simulate various environments for reinforcement learning algorithms, which are a form of machine learning. Okay. So let's go ahead here and take about what is OpenAI, what is this module? We're going to find out here. So what OpenAI is an artificial intelligence research facility that was founded by Elon Musk in order to best determine the path forward to creating safe artificial intelligence. Okay, so something that they have created here is a Python module called Gym, and the Gym again just is a way to create simulated environments in Python and deploy these artificial intelligence agents or machine learning agents within these environments in order to best accomplish the goal that we want to accomplish. Okay. So we're going to talk about now how we can create this script, how we can create this environment, and then what to do next. Okay, so the first thing we're going to do here is, again, import Gym, right? So what you guys want to do is go ahead, if you're following along here, you want to go and pip install Gym. Okay, so open up your command line or open up your terminal and run pip install Gym. All right, and that'll get that module installed on your computer for you. So next thing we're going to do is we're going to import Gym. So we're going to import that module into our script, right? So after that, we are creating this variable called env. So env is going to represent the entire environment that we are creating with the Gym module. Okay, so we're saying env is going to equal gym.make, which is how you initialize or create an environment with using the Gym module. And so we're going to say gym.make, and then we want to pass as a string cart pole -v0. Okay, so that is going to create the cart pole environment that we see being simulated on our computer there. So next up here, what we are going to do is create a function called basic policy. All right. So what is a policy? A policy is the actions that your agent is going to take based on the observations that it makes around your environment. So think about it just for people. Okay. Think about it for us. So when we are going around in our environment or throughout our day-to-day lives, okay, our policy are the actions that we take based on our observations, okay, whether they be internal or external. So say you're hungry, right? That's an observation about your environment, right? You're hungry, right? You want to eat some food. So if you're hungry, your policy in that case is to go and grab a box of cereal and crack it open and pour a bowl of cereal for yourself, right? So your policy is the action that you take based on your observations. Another way to look at that is, say you're playing baseball. Your observations about your environment are say the ball coming in, the speed of the ball coming from the pitcher, and you're up at bat, right? You're up at bat, you're ready to hit the ball. So your observations are the ball coming in and the bat in your hands, and then your optimal policy are like the angle of how you're going to swing the bat in order to hit the ball, and say you want to hit a home run, right? So that would be your policy. Your policy is the actions that you take based on your observations about your environment. Okay. So right now we're creating the policy for our cart, right? So we want to know, in order to balance that pole, in order to maintain the balance of that pole on top of our cart indefinitely, we want to establish the best policy, so the best action that we can take based on some observations about our current environment. Okay. So what we are saying here is we are creating a variable called the angle, and that is going to be equal to the second index of the third item in the observation list. Okay. So we're going to talk about what OBS is in just a second, but for now you just need to know that the angle is the angle of the pole as it is on top of the cart, right? So if it's tilting to the left or tilting to the right, that is the angle, okay? So our policy is going to decide that we should move our cart to the left or move our cart to the right based on the angle, the current angle of the pole in our simulation. So in this case, we have two actions, right? So in this case, our cart can only take two actions. It can only move left and it can only move right. We're going to run our simulation again here so you guys can see, okay? So here, again, here's our cart. Remember, it's only moving left or right. It can only move along our x-axis, right? So it can only go left, it can only go right. So now we've got that. So what we want to do is we want to say, again, based on the angle of the pole, based on whether it's going to the right or the left, we want to decide what should we do? What should our cart's like, what's my policy? What should I do? Our pole is tilting, that's my observation, but I'm trying to decide what to do based on that, right? So we say here, what we're saying is that we want to go left, so return 0. In this case, 0 is to go left and 1 is to go right? We have a binary options. We have two options. So in this case, we can either go left or right. So we can go, so if the angle is less than 0, right? So if the angle is tilting to the left, or this camera's backwards, okay? So tilting to the left, right? Then we want to go to the left as well, right? To maintain that center balance. So if it's tilting to the right, there we go, tilting to the right, then we want to go to the right, in order to maintain that balance as well. So that's what that policy is going to do. And this is an important part because later here, this is where we are going to implement our neural network, okay, in order to create this. And it's really exciting stuff, guys. So we're going to talk all about that in our next video. But for now, we're just going to go over how to create this simulation, this basic simulation. Okay, so next up here we have totals, and totals is going to be the list of the accumulated rewards for each episode. So let's break that down. What does that mean? So our agent basically in each simulation, see, we're running a bunch of different, when we run this program, each flicker that you see, right, is the simulation ending in this case. So we're telling our program to run a bunch of different simulations here. So each flicker you see there, that's when it ends. That's when the pole is about to fall. It'll automatically end when the pole is about to fall. We'll talk about why that is in just a second. But so yeah, that's what's going on there. So we want to determine how long was the cart able to maintain the balance of the pole. Okay, so that's what our totals is going to be, and the way we do that is at each time step. So you can kind of think about this as each second, right? But not really. But it's in that sense, it's a time step. It's a unit of time. It's a unit of within our simulation. Okay. So basically, if the pole is still standing for each unit of time within our simulation, then we're like, okay, you get a reward, like good job, cart, like nice job, okay? Same way when you're training your dog, right? It's like, okay, if your dog did the right thing, then yeah, you give it a treat, good job, you get a reward, okay? So next up here we have our episode. So we're creating a loop here, and this is creating a loop for the number of simulations that we want to run, okay? So we're going to say, for each episode, so we're creating our for episode, which each episode is going to be represented by the episode variable. And so we're saying basically what this loop is saying is run 1,000 simulations, okay? So next up here, we are creating a variable called episode rewards. And in this case, this is where we are going to, this is the variable that is going to keep track of how much reward, or basically how long in this case. The reward will change based on the kind of simulation you're running. But in this case, our goal for the agent is to maintain the balance of the pole for as long as possible, right? So we're saying we've got these episode rewards, and this variable is going to be the amount of reward, or however long in this case our cart manages to maintain the balance of the pole. Okay, so again, after each episode, we append, or we add these episode rewards value to our totals list up here, right? Because we want to keep track for each simulation how long the cart was able to balance the pole based on the policy that we created up here, okay? All right. So remember, our policy is just if the pole is to the left, then go left, and if the pole is leaning to the right, then go right. But again, that doesn't account for a lot of other variables that are happening, a lot of other things that are occurring within our environment. So it's not going to be the best policy, obviously. But this is just for the purpose of getting our simulation up and running. Okay, so next up here we have a variable called OBS. This stands for observations, and this is going to observe the basically the variables that make up our environment. So back to our baseball analogy. Imagine you have a pitcher that's throwing the ball, right? The ball is coming in at a certain velocity, and the ball is coming in at a certain angle. So those are two variables that we can observe about our environment, and we also can observe like the weight of the bat. Okay, we can observe the weight of the bat, we can observe the angle of our arms as we're about to take that swing, right? So those are a couple different things. We can observe, say, our feet position. So these are all variables that we can observe about our environment that can help us determine the best policy or the best action to take. Okay, so what we are doing here is we are saying OBS equals env.reset, which is a function from our gym module. Remember, and we created this env, which is the environment that when our gym module creates the environment, and then we're saying we're calling the reset function on our environment, which basically all this does, don't get confused with reset like resetting the whole simulation. It doesn't do that. All it does is return the values that are the observations about our environment in our current time step, right? So in our current state. So what is that? Our state is like the current position or the current like speed of everything or velocity of everything that's happening in our environment. Okay, so if you can imagine, again, back to our pitching analogy, back to your hitting. Okay, if each time step would be, say, so the ball is released from the pitcher's hand, freeze that frame, that's a time step. Move the ball another like inch, right, that like towards the plate, then that'll be another time step. And as the ball is traveling through the air towards our bat when we're at plate, then that is going to be those are going to be individual time steps where we can observe changes in our environment. So what we are doing is we are saying the OBS variable is going to represent the changes that we see in our environment, and we are going to repeatedly observe our environment after taking actions as dictated by the policy that we created. Okay, so next up here we have a variable called action, right? And action, we're just going to initialize that at 1, and this is going to be whether we want to move our cart to the right or to the left. Okay, so again, we've only got 2 actions we can take in this case. We can only move left or right. In other environments, you might have lots and lots of actions. Like, just think about yourself. Okay, how many actions can you take when you get up in the morning? You can take a lot. You can take a lot of actions. You can get out of your bed, you can go eat cereal, you can pick your nose, you can do a bunch of stuff. I'm not saying pick your nose, but that's an action you can take. Okay, so next up we say 4-step in range. So this is where we have this is the loop that is going to determine the action that we should take at each time step. Okay, so we're trying to stay alive for a total of 1,000 time steps. So when I say stay alive, I mean keep balance of the pole, right? We want our simulation to run for 1,000 time steps if it can. So later, ultimately, we want to solve this whole thing. We just want to be able to indefinitely keep that pole balanced. But for now, we're just saying, okay, let's try to survive for 1,000 time steps. Let's try to keep this pole balanced for 1,000 time steps. Okay. So next up here we have our action. Our action is the policy. So this is going to represent the value that our policy tells us to take based on the observations of our environment at this current time step. Okay, so we're saying action equals basic policy, the basic policy function that we created, right? And we're passing it the observations. So we're passing it the values that are the variables that we are in our environment, right? So remember we talked about that, like what that is, like the speed. In this case for the cart pole, it is the location of the cart on our x-axis, right? So where is it in our simulation? It could be way off to the right, could be way off to the left. I should have done that backwards, way off to the right, way off to the left. But anyway, so that's one variable that we can observe about our environment. Another variable is how fast our cart is moving. So what is our velocity to the left or to the right? A third variable is what is the angle of the pole that is on top of the cart? And then the fourth variable that we are going to observe about our environment is what is the velocity that our pole is falling to, right? So how fast is it falling towards the left or towards the right? So based on those 4 observations about our environment, we are going to determine our policy, what action we should take based on those observations we can make about our environment. Okay. Next up here, we have a function called our Env.Render. So what that is doing is that is just rendering the environment so we can see it in our little pop-up square when we run this script, right? So we can see what's going on. So after that, we have these 4 variables. We have OBS, right, which is going to be our observations about the environment. So that's a list. And then we have our reward. So in this case, the goal in this simulation is just to try to keep that pole balanced as long as possible. So that means at each time step, right? So remember, at each freeze frame, we are saying we want to determine whether or not our agent, so our cart, deserves a reward, right? So in this case the objective is to maintain the balance of the pole. So at each time step, if the pole is still balanced and not fallen over, then we're like, okay, good job, like you kept our pole balanced, right? Next up here, we have our done variable. So what this variable right here this is just going to represent true or false. So in this case, the environment that is created by the OpenAI gym, it will tell us if the pole falls too far to the left or the right. It's going to tell us that, okay, your simulation is over, you failed, it's done. So in that case, true, you're done, okay? Otherwise, it just says false, and then we can keep running our simulation, okay? Next up here, we have a variable called info. This is just for debugging your environment. This isn't too important, so we're not gonna really talk about this one, but when you're recreating this, do have that variable there, because that is a variable that is returned by this function, right? So we're not going to use that, but that's there, okay? So next up, like what we are assigning these variables to is this env.step with action, okay? So this is basically saying, what this is doing is a function that is going to execute the action that was determined by our policy based on the observations we made about our environment. It is executing the best action that we think, or that our policy thinks we should take, okay? Or it's executing the action our policy thinks we should take based on the environmental observations, okay? Next up here, we are updating our reward. So for this run of the simulation, right, because in this case, we're doing 1,000 runs, we're doing 1,000 simulations, right? And we're saying for this run of the simulation, do we want to add a reward? So at each time step, if our pole is still standing, then we want to add a reward. So in this case, the reward is more or less gonna represent how long our cart managed to maintain our pole based on the policy. But so we want to add that reward at each time step. So remember, we took our action, we say we moved right. If the pole is still standing, which we will know whether it's standing or not by whether done is true or false, right? So we know whether it's standing or not, and then we have a reward that is returned. So basically, if our pole is if it's still standing, right, we get a reward. We're a good dog, right? Good cart, and we update our reward based on that. So we add that reward to our total accumulated rewards for this run of the simulation. Okay, so then finally here we say if done. So remember, done is going to return true or false based on whether or not our pole has fell too far. If it falls too far, if it's unrecoverable, it's going to return true. So then if true, we're done, simulation's over, our policy failed in this instance. Then we'd say, so if it's done, if the simulation is over, then we want to go ahead and just add our total accumulated reward, the total amount of reward that our agent accumulated in the environment. So that's like the measure of how good a job it did, right, in the environment. We want to add that to our totals list, and then we go ahead and we break the loop that is determining the action that our agent should take at each time step, right? And then we move on to our next iteration of the simulation and go back and do the same thing. Okay, so after that, we go ahead and we just want to print out totals, right? So we want to see for every simulation iteration, what is the total reward that our agent accumulated, right? And then we want to see what we're doing in our next line here is printing the longest number of time steps the pole is balanced, which again in this case is represented by the total reward accumulated by the agent. Then we want to say add that, which in this case is just going to be a string value, which is the maximum value found within our totals list. Okay, so that's again what it does. We'll go ahead and just run this one more time for fun so you guys can see. So there we go, cruising along here, doing our iterations. I'm actually going to change this up real quick here. So you guys can see this last part, so you can see how terrible this policy is currently. So in this case, you see we run this, and we'll see, we're going for 10 iterations. So each little like flash you see is the reset of the simulation. So we're coming up on 10. There we go. And we've got in our list now, we have, so for the first simulation iteration, we managed to maintain, we got 39 total rewards because our reward is 1, so we stayed alive or maintained the balance of the pole for 39 time steps. Next up, on our second simulation, we were able to maintain the balance of the pole by 55 time steps, for 55 time steps. Third iteration, we maintained balance for 40 time steps, okay? And then the maximum number of time steps we maintained balance was 56. So that's terrible, right? We wanted to try to survive or maintain balance for up to 1,000 time steps, and based on this current policy, we only got 56. But in our next video, we are implementing a neural network for this reinforcement learning problem, and we are going to see how this neural network can actually just solve this entire problem for us and indefinitely keep our pole balanced. So our neural network is going to determine, based on those 4 environmental variables that we established, what the best policy at every time step is to take, and then it'll go ahead and it's going to solve this whole thing for us. It's going to be our intelligence agent within our simulation. Okay, this is super exciting stuff, guys. I'm really excited to show you guys this next video. All right, so thank you guys for watching. Give this video a thumbs up if you enjoyed it. Be sure to subscribe. Any comments or questions, leave those below. I'm happy to help you guys get this up and running, or if you guys just want to talk about this, like I love talking about this. So thank you guys for watching, and I will see you all in the next video.